Okay, here's a question. How would you make 40 liters of a 0.030 molar calcium chloride solution? So the molarity equation's up at the top. You always start the same. You plug in what you know. I know the molarity is 0.030. Okay, and instead of molarity, I'm going to write moles per liter. That's again what capital M stands for. And then I don't know the number of moles, but I do know the volume. So I plugged in the volume down at the bottom. Okay. To solve for x, I'm going to multiply both sides by 40. These cancel. I get x equals, multiply this out, it comes out to 1.20. And you look at what units are left. The liters here cancel, and I'm left with just moles. So I know I need 1.2 moles to make that solution. Okay, so the next thing, you can't measure moles on a scale, so we need to convert that to a mass. So I've added up the molar mass. Calcium chloride has a molar mass of 110.98 grams per mole. So if I want the mass, would just take 1.2 moles. I need to multiply that by its molar mass. You can see the moles cancel, and I end up getting, let's see, comes out to 133 grams calcium chloride. Okay, so that's how much salt, calcium chloride salt, you would need to add. The physical process of making this, 40 liters is a large volume. So you would need a big bucket, about 10 gallons. You'd need to know where the 40 liter mark is. And you would take your 133 grams of calcium chloride, you would put that in, right? So there's our solid calcium chloride, weighed on a scale, dumped in. And then you don't just add 40 liters of water. What you do is you start filling it up with water. Fill and fill and fill until your solution reaches the 40-liter line. Oops, you will. And then once you've done that, you stir. What that does is it distributes all these calcium chloride particles equally and throughout the solution. So then your concentration is correct. Okay, so that's how you make a solution. Your final volume needs to be that 40 liters. Okay, so here's a little follow-up. What would happen to the concentration if you added additional water and you brought the volume up past the 40 and you went to 60? Well, we know when we add water to things, it's going to dilute it. So the dilution equation, molarity 1 times volume 1, that's like our starting conditions, equals molarity 2 times volume 2. So I'm just going to take the original molarity, the original volume, N equals the new molarity, which is unknown, times the new volume. Okay, and so I only have one variable to solve for, so I would divide both sides by 60. Here they cancel. The new molarity would be, and you guys can look, 40 over 60 reduces to 2/3. So what I have to do is multiply 0.03 times 40 divided by 60, which is 2/3 of that, comes out to 0.02 moles or molar is the new concentration. So originally it was 0.03. Once you dilute it, it's 0.02. Okay, what would happen if you went the other way? You were trying to evaporate some of the water. You left it outside. What happens if the volume went from 40 to 20? So we could plug it into the equation. Here's the original times our original equals molarity 2 times, this time it's 20 liters. I'm being a little less careful with sig figs. I want you to look at the dilution factor. I'm going to divide both sides by 20. Check this out. So 40 over 20, this time because you've evaporated some of the water, the concentration 40 over 20 is 2. So you've effectively doubled the concentration. So instead of 0.03, get 0.06, and I should be good. I should put moles per liter or capital M for molar. So this time the concentration went up because you cut the volume in half. Okay, so I'm going to stop the video here.